Right, so that's a CH3 on the end, and this is a CH2, right? And then the other carbon here, you see how it says COOH?
Yes.
Okay, so let's think about that. So one of the bonds is already taken up here. So that means that carbon has 3 bonds left. Is that right?
Yes.
Yes.
Mm-hmm. So you got 3 bonds left, and you got 3 atoms left. But carbon can only make 4 bonds. So this is a good place to kind of make a point about functional groups and also about how carbon forms its bonds, right? So if I did this, if I just put an O on carbon like this and an OH on carbon, I got a problem, don't I? What's the problem?
You only have 3 bonds.
I only have 3 bonds to it. So now that's a great place to talk about filling out the octet of carbon, like in a Lewis structure. What would you do to carbon? What do you need to carbon to give it a full octet?
Double bond.
You need another bond. Where? So now here's the question: where are you going to put the double bond? Do you put it here, right? Or are you going to put it here? Which one do you think?
The top.
I'm going to put it here. I'm not going to put it here because if I did that, then that would change the charge on oxygen and it would give me an unstable molecule, right? We're going to talk about formal charge today too, so don't panic about that. But here's a great a great little piece of information right here. So you see this right here. This is a very common functional group that carbon is involved in, and it's called a carboxylic acid. Right, it's called a carboxylic acid. It's one of your major functional groups in organic. Even though we haven't started functional groups yet, it's good to start looking at this stuff and kind of getting an idea about what's what, right? So it's a carboxylic acid. It's a carbonyl. This part right here, the C double bond O, right? This is what you call a carbonyl. Let me see if I can get some room to write. Yeah, right there. It's called a carbonyl. That's carbon double bonded to oxygen. That's a generic functional group. When you start attaching stuff to it, then that changes the character. So it can be a carboxylic acid, it can be an aldehyde, it can be a ketone, it can be an amide. All these different functional groups are possible, but they all contain that carbonyl moiety, right? Questions about that? All right, let's think. I want you to, let me give you a little bit more information on that since we are already there. That carbonyl.
Dr. Russell.
Go ahead.
So we can leave the OH as it is.
Mm-hmm.
Okay.
Yeah, because both of those things are bonded to carbon. That's why I wanted to show you that, so you didn't think that the OH was bonded to oxygen. Are you following?
Okay.
That's why I wanted to draw it out, because that OH group is a part of the whole functional group. That's why I wanted to show you what it looks like. So if you see it again, you won't say, oh, I need to put the OH on oxygen because it's next door to it. All right, that's not, for this case, you don't do that. That's the different, that's why you put certain things in. Remember the other day we had certain things in parentheses?
Mm-hmm.
That's why you use the parentheses, right? To show that that group on the right is bonded to the atom to the left of it. There's no parentheses here. So all of those atoms, both oxygens are connected to carbon.
Okay, thank you.
Yeah, no problem. Good question. So you'll see it written this way, COOH. Sometimes you'll see it written this way, CO2H. They're both the same. When you expand them out, both of those are abbreviations for that carboxylic acid. Any questions about that? No questions. So now you know what a carbonyl is, and you know one of your major functional groups, which is a carboxylic acid. We're gonna talk more about that in the next unit. But while we're here, we might as well introduce some more information because all of it's connected anyway. All right. Let's do B. I want to see how well you pick that up. Let's do B. Is anybody still writing the structure out?
Yes. You said B or E?
No, we're going to do E, but I want to do B right now because I want to see how well you pick that up, what we just talked about. Can I erase the A? Can I erase A?
Yes.
All right. So that was A. Let's look at come on, eraser. Do what I told you. Let's look at B. Right? And it's asking again, draw the Lewis structure. So you got to show all the bonds. So I'm gonna put the CH3 out here, and that's connected to a carbon next door to it. Now look at the groups, look at the atoms to the right of carbon. Right? What do you think about that based on what we just did up top?
We're going to have another double bond.
It's gonna be some type of carbonyl compound in it. So let's look at what we can do. So here's the CH3. We're following that. And then now we have carbon. We know there's an oxygen on it, right? We know there's a nitrogen on it. Is that right? Now there's a temptation to put the CH3 here. Because up top, when we had COOH and we kind of put the OH on carbon too. But if we did that and left the nitrogen out here kind of butt naked, we got a problem, right? Because nitrogen doesn't have a full octet, even though carbon does. And since there are no charges, everything has to have a full octet and be neutral. So that's how we know the CH3 doesn't go on carbon, right? It goes on nitrogen. And then nitrogen also has a lone pair. Now, what are we missing?
Double bond.
A double bond to oxygen. Good. Right? That's the Lewis form for that compound. This is another functional group. What's the C double bond O called again?
Carbonyl.
It's a carbonyl. But the fact that, so there are a lot of different types of carbonyls. The fact that I have a nitrogen out here, and I know I'm kind of throwing in these functional groups, but I don't, we got to learn them anyway. The fact that there's a nitrogen connected to that carbonyl, this is a totally different type of functional group now. It's not an acid. This is what we call an amide, A-M-I-D-E, amide. Functional group.
Dr. Russell,
Go ahead.
can you explain why the CH3 goes on the end, nitrogen and not the carbon again?
Yeah. So if I don't put it there on nitrogen, nitrogen has a negative charge. And then this, let me take the double bond out. If I put it here, right? Are you following?
Yes.
So when you look at that B, are there any charges in that compound?
Say that again. Are there any what?
Any charges, right? Is there a negative or a positive sign somewhere to tell you that that compound has a negative charge in it somewhere?
Next to the end, or you saying next
Anywhere.
to the oxygen? Oh, anywhere now.
I'm talking about in the condensed form.
Oh, yes. Sorry. Yes.
There's no charges in there, right?
Yeah, that's what I just said. Okay.
Yeah, so the fact that you don't see a charge anywhere in there, that's telling you that the whole thing has to be neutral.
Oh,
You follow
okay.
what I'm saying? And so if I
Yeah, I
put
follow now.
CH3 there, I got to make the nitrogen, I got to fill up its octet. So I put an extra pair of electrons, that's going to make it negative. So that's how we know. So
Okay.
as a rule of thumb, sorry about that. So as a rule of thumb, when you see CO, like we have here, and there's no parentheses, it's understood that that's a carbonyl.
Okay, I understand now.
Right?
Thank you.
So once you throw the carbonyl in, then you know that carbon can only form one more bond, right?
Mm-hmm. Got you.
All right. That's a good question, though. Thank you for asking.
Dr. Russell,
Go ahead.
can you explain why the carbon with that oxygen has a double bond?
Yeah. So if I let's say I don't put a double bond there, that's a great question. How many bonds does it have without the double bond?
One.
It's got a bond here, here, and here, right?
Mm-hmm.
So if it's got 3 bonds, but carbon normally forms 4 bonds, what's going to happen is that carbon is going to be positive. We're going to get the formal charge in a little bit. But again, there are no charges in the condensed form, are there?
No.
Right. So I can't have that. I can't put a charge there if there's no charge in the condensed form. Right. So that means that carbon is neutral and it has a full octet. The way you give it a full octet is to make sure it has 4 bonds to it. So I put the double bond in to give carbon its 4th bond.
Okay, thank you.
That's a good question. All right. One more I want to make sure you got it. So let's do one more. What do you think about C? Somebody can just tell me what they would do with C. Just take your mic off mute and then just give me some insight, because I don't know. I don't know what to do with it. Well, I do, but you know.
First, I would put the carbons out, like take out all the carbons.
Like this. Uh-oh, not like that now. Sorry. Like that?
Yes.
Got 3 carbons in there, right?
Yep.
Now, so this is a CH3, we're done with that. What would you do next? What does that CO mean when you see C and O together like that?
Carbonyl. You'll make a carbonyl group.
Right? I'm telling you that so that you can recognize that immediately. Or if I see CO together and I don't see a parentheses or I don't see a OH or something like that next, I know it's a carbonyl.
Okay.
Right?
Then
That's easy to identify. Now what? That carbonyl is done, isn't it?
Mm-hmm.
So now what's left?
The CH2. And then you add the Br at the end. Or at the last one. Mm-hmm.
Man, I didn't realize this was going to be so much information. I love these types of problems, though, because you can kill a lot of birds with one stone. This is another type of carbonyl. Do you see on how the C double bond O you got on either side a carbon bond? You see how you got a carbon bond here and a carbon bond there to that carbonyl?
Yes.
Mm-hmm. So here's the carbon of the carbonyl, and then on the left and right side, it's bonded to carbon. So this is a different type of carbonyl. This is what you call a ketone.
It's in the middle.
Mm-hmm. So the carbonyl is in the middle, and on either side of it, it's a carbon bond. Notice with the carboxylic acid, what was on one side of that?
Was it a oxygen?
It was an OH, right?
And a hydrogen.
What about the amide?
It was an N.
A nitrogen, right? Do you see how all you got to do is change one connection, right? And that's going to change the whole molecule. It's going to turn into a whole different functional group. Just by changing one atom. So I want you to get used to that, right? Because learning functional groups is just memorization. right? But if you can recognize them, then you know what they do, because every functional group reacts in a different way. All right, let's go over here to
I have a question.
come on.
For the BR
Mhm.
for C, why didn't we put the H under the C and then the BR all the way to the right?
You mean over here? You want to put bromine here?
Yeah, why didn't we do that?
You could do that. It
Oh,
doesn't
I
matter.
can do that.
Yeah, you can put it.
Oh.
All three of those spaces are available, and you can rearrange that however you want to.
Okay.
Yeah, it's not that's semantics. Right? There's nothing that says BR has to be on one of those sites on carbon because they're all equivalent.
Okay, thank you.
Yeah, great question. All right, let's go over here to H. Let's see if we can tackle this one. What is this right here?
Carboxylic acid. Wait.
Come on. Who was that?
Oh yeah,
Who was that said that?
me.
Who is me?
Aria. I'm sorry. I'm Aria.
Okay, good. You're right. It's a carboxylic acid. How you gonna write that?
The double bond on oxygen.
Right. Remember, I just gave you that abbreviation CO2H. That's one of the abbreviations for carboxylic acid. Are you following?
Yes.
And then what's next? There's a carbon here. Is that right? Now look what's next to that carbon. What is it? What does that parentheses mean? We talked about this Monday.
It bonds to the right, right?
Hmm?
Didn't you say like it bonds to the right of the carbon or something like that?
No, it's bonded to it's to the right of the carbon. In parentheses, that means it's bonded to the carbon next on the left of it.
Mm-hmm.
So it's bonded here. Is that right?
Yes.
So it's going to be right here. So CHOH is going to look like that, right? And then what's on the other end?
Question, is there a reason why you did HO to the carbon to the left?
What you mean? Not why I didn't write it like this?
Yeah, does it matter? No, I'm talking about to the left over there. By the other seat.
Oh, yeah. Right here?
Yeah.
Yeah, that's a convention. I do that because I want to show that it's this atom bonded, right?
Oh, okay.
Follow what I'm saying? Because that's
Oh, wait.
the oxygen that's bonded to carbon.
Never mind, I'm looking at the wrong thing. Okay, I see what you did. Okay.
Yeah. If I had written it like this, then it might confuse you, right? Because then you'll think hydrogen is bonded to carbon, but it's not, because hydrogen can only make one bond, right?
Does HO stand for something?
Yeah.
I'm just
say that.
Before.
It's an OH group. It's just I just wrote it in reverse.
Oh, it's just backwards. Okay.
So this is called what you call a hydroxyl group.
Hydroxyl, yeah.
Right? But right here is not a hydroxyl. It's an alcohol. Man, I didn't realize this problem was loaded like this. It's an alcohol right here.
It's an alcohol because it's in parentheses.
Because it's bonded. So the alcohol functional group has a singly bound OH group to carbon, right? It can be the other three groups can be anything, right? But if it's a carbonyl, then it becomes an acid. Right? But if it's just a carbon with 3 sigma bonds to it and 1 bond to OH, it's alcohol.
Okay.
If it's just by itself like this, wrong button. Like this, we just call it a hydroxyl group, right? Like if it's over here on the acid, we call it a hydroxyl group.
Okay.
Why does adding the other oxygen make it an acid?
No, it's adding a carbonyl that makes it the acid. It's this part that makes it the acid.
Oh, okay.
So, Dr. Russell.
Yes.
Because it can only have 4, is that the reason why the O is not under the C? The oxygen is not connected to the carbon under it?
On the acid, you're asking that about the acid?
Yes.
It's still, you mean why didn't I draw it like this?
Yes.
Okay, that's a good question, right? Let's think about it now. Let's go back to the hybridization part. What's the hybridization state of that carbon?
SP3.
You said sp3? How do we tell the difference in the hybridization states? We look at the number of groups. Can we do that? Is that right? Can we do that? Look at the groups?
Yes.
Yeah.
And this has, let me get a different color. This has this carbon right here now has 1, 2, 3 groups attached to it. So it's sp2. Are you following?
Can you share the screen again? I don't think I can see.
Hold up. What about now?
I'm gonna try to come back out, close the app and open it.
Okay. So if it's sp2, what's the geometry?
Isn't it trigonal?
Yeah, it's trigonal. That's why I drew it like that. Because even if I drew it underneath, the carbon is still gonna have 4 bonds to it. Like if I drew it like this, it's still gonna have 4 bonds to it. It doesn't change the bonding. But I drew it out here on purpose because I want to keep that geometry consistent. Did that answer your question or no?
I was more so asking why not the oxygen itself, not the hydrogen.
But the hydrogen is attached to the oxygen. They're together. They're a group. Like the OH is the hydroxyl group. It literally looks like this.
Okay.
Right? So wherever that oxygen goes, the hydrogen goes with it.
So the 3 groups are the 2 alcohols and the 1 ketone?
It's the hydroxyl, the oxygen and the carbonyl, and the carbon to the right of it. You see the carbon is circled in green?
Yes.
Yeah,
Okay.
those are the 3 groups that are attached to that carbonyl carbon. That's what makes it sp2 hybridized.
Okay. So when we're looking at the groups, we're looking at the central atom, which would gonna always be carbon, maybe?
It won't, not always now.
Okay.
Other atoms I'll show you on this example, I can actually show you this. So let me put the other acid in, because there's another acid on this side, right? Is that right? So you actually had 2 acids, one on the right side, one on the left side, and in the middle part you had alcohol. So let's look at this oxygen right here, because it's got 2 lone pairs, right?
Yes.
And so does this one and this one. But what's the hybridization state on this oxygen right here? Let me see how you're thinking about that. How many groups does it have around it?
2? Wait, no, 1.
So let's think about this now. Remember we talked about all that orbital stuff?
Yes.
So when you have lone pairs, those lone pairs are not just sitting there, right? They're actually in an orbital, which makes the lone pair and actually a group around that atom. So how many groups does it have around it? 3. It's got the 2 lone pairs, and then it's got carbon down here. Is that right? So 1, 2, 3 groups. So what's the hybridization state on oxygen? Who was that? I heard somebody talking, but it was kind of muffled. If it's got 3 groups around it, then what's the hybridization state? Isn't it sp2?
sp2.
Yeah. Remember, sp3 has 4 groups, sp2 has 3 groups, and sp has 2 groups. Yes or no?
Yes.
All right. All right. Let's keep. I want you to practice those because you're gonna see that again. So if you have questions, you can ask them now, but you're definitely gonna see that again. Go ahead. Let's move on to 166. That's a good question too, because we can throw in some more of this information in 166.
Dr. Russell.
Go ahead.
I'm sorry. Going back to H.
Go back to H.
Yes, I'm sorry.
That's okay.
I just noticed this. Did you do when you have the 3rd carbon? Is that an oxygen with lone pairs?
You talking about the one right here on the end?
Yeah.
Yeah. So if you remember from Chem, right? If you have an oxygen, right, it's group 6. Am I right?
Yes.
So it's got 6 valence electrons. So 2 here, 2 here, 1 here, and 1 here. Are you following? So if that oxygen makes a bond using these 2 electrons, then it's got 2 lone pairs left over.
Oh, okay.
Yeah.
I'm with you. All right.
So that's why anytime you see an oxygen with 2 bonds to, we're gonna talk about that in a minute. But if you see it with 2 bonds to, it's got 2 lone pairs on it. Some books show it, some books don't.
Okay.
Yeah. But
all oxygen should have lone pairs attached.
Yeah.
Okay.
Let's do some of these examples down here. Actually, let's do 166. Let's do B, because that question is getting at what you were asking. And let's do D. And that'll give us a chance to talk about lone pairs, hydrogens, and formal charge. All right, so somebody read that question in 166. What is it asking?
Draw in all the hydrogen atoms in non-bonded electron pairs.
So it's asking you for 2 things. It's asking you to draw the hydrogen atoms and electron pairs.
Oh.
Are you following? Those 2 things. How are you going to put in the hydrogen atoms on B? What do I need to put in first in order to show the hydrogens?
The carbonyl group.
Okay, so I got the carbonyl right here. That's straight. But what about out here? Right, don't I need to show the carbons? I need to show these carbons, don't I?
Right.
And then on the carbons, I can show where the hydrogens are. Following?
Yes.
What about on that other carbon? Because that carbon, I'm gonna draw that negative sign out here. It has a negative charge on it. Right?
So
What do
have
negative?
2 H's, maybe?
Say again?
2 hydrogens?
It's got 2 hydrogens. Good. Who was that?
Amaria.
Man, you on it today. That's good. You must have ate your Wheaties this morning.
Thank you.
So now, how do we account for the negative charge? That's the question. Right? How do we account for the negative charge? Because we got to account for it because it's there, right? Now let me ask you, in general chemistry, when you took Chem, what normally causes something to be negative?
Extra electron.
Extra electrons. That's exactly right. See the second part of that question? Ask you to draw in the non-bonded electrons. That's why that part of that question is there. So we put the H's in. Now we need to figure out how many electrons do I need to put on carbon to make sure that it has a negative charge. So the way you calculate formal charge is I know you learned it in Chem, the bonded electrons minus half of non-bonded or something like that. But I'm just going to give you a simple way to do it. It's valence. So to calculate formal charge is going to be valence minus actual. Following?
Yes.
So the charge on carbon, so the formal charge in this case is -1. I'm doing this in this way, but there's a shortcut too, but I'm gonna do it this way first. So -1 and equals 4 minus x. How do we solve for x?
Subtract 4.
Subtract 4 from each side. Okay, good. So this is -4 here, and then -4 here. What do I get? -5 equals -x. Is that right?
Yeah.
Yes.
Or what? 5 equals x. Is that right?
Yeah.
So how many? So x is the amount of actual electrons. You following? So how many electrons should carbon have around it? If x is 5, then it should have 5 electrons around it. Yes.
Yes.
If we're doing valence minus actual. I'm gonna come back and tell you an easier way to think about that. But for now, let's say it should have 5 electrons around it. Follow me? How many does it have around it right now? If each bond contributes 1 electron, how many electrons does it have around it?
3.
3. How many do I need to add for it to have 5?
2.
2. So that means that carbon should have a lone pair on it. All right. So now you see, now I have a lone pair, that's 2, and 1 from each bond. That makes 5 total. That's how we got that negative charge. So
I'm
here's the rule of
confused. I
thumb.
only see 2 bonds. I mean, how is it 3?
What about this bond right here?
Oh, okay.
All right. Here's a rule of thumb. If carbon, let me get you a blank page. Actually, let me go out of here and have a new page. So let's talk. Let me give you some info on formal charge right here. For carbon, let's do carbon. So if carbon has, if it's negative, it's going to have 3 bonds to it and a lone pair. This is what we call a carbanion. You remember the anion part from Chem, yes? Anion means negative.
Yes.
So a negatively charged carbon is going to have 3 bonds to it and a lone pair. And then you can see the valence minus actual here. Valence is 4. Actual is 5 because it's 1 electron from each bond plus the lone pair. So that's 3 plus 2 is 5. So that charge is going to be -1. All right. Any questions about that? So to calculate formal charge for carbon, it's the valence electrons minus that's for any atom. Valence electrons minus the actual. All right. What if carbon is positive? Let's see what we can do with that. Right. So this will be what we call a carbo what? If it's positive.
Carbocation.
It's a cation, carbocation, right. Cation is positive, the anion is negative. So you have 3 bonds and a positive charge. Right? 3 bonds and a positive charge. So how do we know that carbon is positive? if we do the formal charge, is valence minus actual, which should be +1. Are you following that?
Yes.
So 1 electron from each bond, that's the actual. So that's 3 electrons. And then the valence is 4. Any questions about that? We're going to do oxygen and nitrogen too. And then we're going to go back to the handout. So let me give you 3 scenarios for oxygen. This is one. These are the 3 ways you'll see oxygen depicted in any problem in this class. That's the other one, and then this is one. All right, so let's calculate the formal charge for each one of those states of oxygen. Let's do the first one. Somebody do the first one for me. What's the formula again? Is valence minus what?
Actual.
Actual. That's the formal charge. So what is the valence of oxygen?
4.
You sure?
No. Is it 8?
6.
6. Remember, it's carbon is 4, nitrogen is 5, oxygen is 6, and then the halogens are 7, and then the noble gases are 8, because they all have a full octet. All right. So the valence for oxygen is 6. So 6 minus, and then how many are around it in this example right
here? 6.
6. Good. So the formal charge here is 0. This is neutral. A neutral oxygen is going to have 2 bonds to it and 2 lone pairs. Y'all following that? Does that make sense?
Yes.
What about the next one? Let's do the next one. What's the valence of oxygen again? That doesn't change, right? It's always going to be 6. How many are around it in the next example? This example right here.
7.
7. Good. 3 lone pairs, so that's 6. 1 from the bond makes 7. Good. Who was that?
Amaria.
Boy, let me tell you, whatever you had in your coffee this morning, drink it every day.
Thank you.
Good. That's good. Keep it coming. All right. So the formal charge on an oxygen with 3 lone pairs and 1 bond to it is -1. Always. This is something you can memorize, right? Now let's look at the next example right here. Valence is 6. What's the actual?
5.
Good. 5. Man, y'all catching it. It's gonna be a good semester. So oxygen with 3 bonds to it and 1 lone pair has a plus charge, right? This is all stuff you can memorize without having it calculated. You understand what I'm saying? I'm calculating it to give you the protocol for how to do it. But if you see it, then you're not gonna have to calculate it if you remember the examples.
Don't these have?
Go ahead.
Don't these like one that is neutral, the -1, and the +1? Don't they have names?
Okay, so here, if it's a negatively charged oxygen, we call it an oxyanion.
Yeah.
And then if it's positive, we call it an oxonium. Not enough room. Let me erase something down here. If it's positive, we call it an oxonium. If it's neutral, it's just oxygen. Is that cool?
Yes, thank you.
All right. What about, let's do nitrogen real quick, and then we're going to go back and look at some more of these examples. So if I have a nitrogen, all right, let's say I got a nitrogen with 3 bonds to it and a lone pair. What do you think? Can you calculate that real quick? What's the valence for nitrogen again?
5.
And how many are around it here?
5. So it's gonna be neutral, right?
Oh, come on. My iPad just died. That's all right. There's more than one way to skin a cat. That's what my mama told me. Let me see. Go to here. So we had nitrogen. This is gonna be a lot crappier though, because I'm writing with my mouse. Here, here, and then here, right? So that was neutral. Yeah, we said 5 minus 5. So the formal charge there is 0. You could also have a nitrogen like this with 2 bonds to it, and then 2 lone pairs. Right? Help me out with that one. What do you think? Valence is 5. What's the action? 6.
Would that be -1?
-1, right? If you ever see nitrogen like that with two lone pairs and 2 bonds to it, is negative, right? That's always. What about if it had 4 bonds to it and no lone pairs? Well, this is negative, by the way.
A +1.
Should be +1. Good, right? Because the valence is 5. And then what's around it, 1 from each bond is 4, right? So 5 minus 4. This looks like some Khan Academy stuff. It's +1. All right? Any questions about that formal charge? Let me see if I can pull this handout back up. Gotta go to Blackboard. I think I have Blackboard. Nope. I had it open earlier. Can y'all still see my screen?
Yeah.
All right. I'm gonna pull a handout back up so we can keep working through it. Come on. Oh, wrong class. That's okay. Same handout. Come on. All right. So we were looking at, which one of these were we doing? We just finished this one, yeah?
We were gonna do D.
B. Or D. Is that right?
Yeah, we're gonna do D.
So let's do that. Let me see if I can annotate this. Where's that? There we go. So we're doing D. Not that D. This D. Excuse the crappiness of my pen. All right. So what is it asking again? Put the hydrogens in. Ooh, that's bad. And then put in what else?
Electron pairs.
Electron pairs. All right, so let's put the hydrogen. Where would the hydrogens be here on D? All right, there's 1 here. Is that right? Yes. And
Yes.
how do I know?
Yes.
How do I know there's a hydrogen there?
There's a carbon there.
Because of
And it's
the
only has 3 bonds.
terminal.
It's actually not terminal, but you can only see 3 bonds to it, right? So the 4th bond is understood to be hydrogen.
Okay.
Are you following that? Now
Yes.
this is terminal right here. What is that?
Okay.
Is that a CH3?
Yes.
At the end of every line is a CH3. Following?
Following.
All right, so what about here? How many hydrogens should I put there?
2.
Just 1, because it's double bonded.
You got a double bond there, right?
Okay.
Right?
Mhm.
Double bond is 2 bonds. You got a 3rd bond on this side, so this carbon only needs what? 1 hydrogen. Following?
Yes.
Because the total number of bonds has to be 4. If there's no charges, then that carbon's got 4 bonds to it.
Okay.
Right? If you don't see a charge, it's understood that it's got 4 bonds to it.
Okay.
What would you do here?
Another hydrogen.
It's 1, right? Because that's a double bond right there to that carbon as well.
Mm-hmm.
What about here?
The same thing.
Same thing. If the carbon is in a double bond, then we put in that 1 hydrogen to complete the octet, right? To fill it out. That's a crappy looking hydrogen, but don't charge it to me. Same here, right?
Yes.
All right. Now I saved the other carbon for last. I think I can zoom in on this. Hold up. Let me see if I can zoom the screen because I got to make this clearer. That was dumb, but that's okay. We're gonna roll with it anyway.
Dr. Russell.
Right. Yes.
Do we need to draw the carbon and the hydrogens attached to it for the terminal?
No. Well, yeah, because it did ask you for all the hydrogen atoms, didn't it? So we'll draw that in. You saw the other ones, right, before I zoomed in, so I don't have to redraw them. All right, let's look at this carbon. What am I missing? How many bonds are shown?
2.
2 bonds are shown. How many bonds does it need?
3.
It's got to have 3, right? Because of what? Because of that plus charge. So what do I need to draw on that carbon?
A hydrogen.
A hydrogen. And it's out here. I'm going to draw it right here because I'm trying to maintain that geometry. Are y'all following that?
Wait, can you explain that one more time?
Mm-hmm. So the carbon itself is positive. You see the charge out there?
Yes.
So that positive charge is telling you, anytime you see a plus charge, what that's telling you is that carbon is electron deficient.
Right.
Missing something. So in this case, it's missing a bond, right? Because it's missing a pair of electrons.
Mm-hmm.
Does that make sense?
Yeah.
And then
so,
an example, we just showed that if you have a carbon that's positive, it's got how many bonds to it?
3.
3 bonds.
Okay.
So you see the 2 carbon-carbon bonds to it right here and here, right?
Mm-hmm.
So the 3rd bond by default is hydrogen.
Okay, so when there's a negative, does that mean that the carbon has 5?
It's got 5 electrons around it, yes, but it can't make 5 bonds. It's going to have 3 bonds too, but then it'll have a lone pair.
Right. Okay.
Like this carbon over here that we just looked at.
Mm-hmm.
Right? It was a CH2, but it had a lone pair to give it that negative charge.
Mm-hmm.
Does that make sense?
It does.
All right, let me tack on something to this problem. What's the hybridization state of this carbon? Right here. I'm gonna circle it. This one. What's the hybridization state? Who that? Say that again.
SP2.
Who is that?
Soraya.
All right. You're right. That's great. Keep it coming. It's SP2. How do you know?
There's 3 regions.
3 groups, 3 regions. All carbocations are SP2 hybridized. You should write that down. That'll take me 3 hours to write with this mouse pad. But all carbocations are SP2 hybridized. Right? Because I'm trying to keep folding in the other concepts that we've been learning. I don't want any of that stuff to get lost in translation. All right, what about down here? Let's look at this one again. What about this carbon? What do you think the hybridization state is? It looks like this now. I'm gonna put the. It looks like that. Y'all see that? I'm gonna help you. Help you think about it. What you think?
SP3.
It's SP3. All carbocations are SP3 hybridized. Because remember, the lone pair, don't think it's just sitting there now smoking a cigarette, just hanging out. It's in an orbital. And that orbital has a shape. And because it has a shape, you can count the lone pair as a group. Does that make sense? if the orbital is filled, you count it as a group. Because the sp2, the carbocation here is sp2, but that also has an empty orbital, but there's nothing in it, right? So you don't count it as you can't just count the orbital as a group, but you can count the pair of electrons as a group. Is it clear? Is everybody okay?
Yes.
Any questions about this? You see how all these concepts merge together? Like everything is it's like Lego blocks. That's why I'm spending so much time on this front end. So when we get to the back end, it's cake. All right, so when we come back on Friday, I'm not gonna start a new section Friday. I wanna work through this handout some more. But we're gonna, on Friday when we come back, we're gonna look at this problem, 169, and then we're gonna look at 170, and then we're gonna look on this back page. We'll start out with formal charge. So we're gonna start out with this on Friday, calculating the charges. And then once we do that, 169, 170, we're gonna go back here and start working through this handout, this part of the handout. Because I sent that video on dipoles and all of that. So we're gonna start doing that, and polar covalent bonds. So we're gonna start doing that Friday. So if you need to rewatch that, do it. If you need to read that section again, do it.
I have a question.
Go ahead.
Should we be expecting like a quiz to come with the videos whenever you send them out?
Yeah, I don't think, let me look on Blackboard real quick. Because I think that in that first module, there was only one quiz.
Right.
Yeah, but normally there'll be a quiz for every video, but whatever quiz is in the module, those are the quizzes you have to do.
Okay.
And most of the time they are related to what the content of the video. Okay. 99% of the time. I think that quiz one didn't have anything on it about dipoles or skeletal and line forms, but you're gonna see that so much, and especially in the second and the module 1A, you're gonna see more of that. So you'll get exposed to it a lot. Any other questions about anything that we talked about today?
You will post the today's lecture on Blackboard, right?
It's gonna be, so I sent out a announcement on Blackboard with a link to a YouTube channel, a YouTube playlist. Save that link, because Blackboard can't hold like all of these big giant 100 megabyte videos. So I'm just gonna post it to YouTube.
Okay.
Let me show you right now. Let me find my playlist. Hold up. Why is that playing? Okay. So this playlist right here, 320 virtual lectures. I sent out like 3 videos from the 14th, and then I sent out the video from the 17th. So we got all those videos already up, and then today's video I'm gonna post as well.
Okay, thank you.
Yeah, because I found out on accident that I don't have to chop them up anymore. I guess I got enough subscribers now that they'll let me post longer videos. So I don't have to chop it. As soon as it's done getting converted to MP4 today, I'm uploading. Yep, good questions. Any other questions? All right, so no other questions. I'm gonna end the lecture now. Keep practicing the stuff that we've done already. Go back, even if the problem is not something that's assigned, go back and keep working. That's the only way you're gonna catch it, is to keep practicing. And when come Friday, we're gonna just keep working through this handout.
Okay, thank you.
All right. Thank y'all for logging in, and I'll see you on Friday.
Thank you.
Thank you.
Okay.